Hi children, hope that all of you are safe. In this video, we can revise the main topics of our first lesson. Our first lesson is chemical reactions and equations. In this lesson, first we have studied about chemical reactions. What do you mean by a chemical reaction? Any chemical change can be called as a chemical reaction. And what is this chemical change? The change in which the original substance lost their identity and form new substances. That can be called as a chemical change, and the process involving in a chemical change can be called as a chemical reaction. In a chemical reaction, some substances are undergoing changes and we are getting new substances. So the substances which are reacting together, or the substances which we are taking originally, they are known as the reactants, and the newly formed substances are known as the products. Then, what all changes we can observe during a chemical change? They are known as the characteristics of chemical reactions. First one, formation of a precipitate. A new substance will be formed. Sometimes it will be insoluble in water. That is known as a precipitate. So, formation of precipitate, evolution of gas, change in color, change in state, change in temperature. These are the observable changes during chemical reactions. Now, this chemical reaction we can express using the short forms. That is known as a chemical equation. The shorthand method of representing a chemical reaction in terms of symbols and formulae of reactants and products. That is known as a chemical equation. And the chemical equation in which the number of different elements are equal on both sides. That is known as a balanced equation. In a chemical equation, if the number of atoms of different elements are equal on both sides, in the reactant side and in the product side, that is known as a balanced chemical equation. For example, here one equation is given, that is 2Mg plus O2 gives 2MgO. In this, the number of magnesium atom in the left hand side, that is in the reactant side, is 2, in the product side also 2. Like that, the number of oxygen atom in the reactant side is 2, in the product side also 2. So here the numbers of magnesium atoms and oxygen atoms are equal on both sides. So this equation can be called as a balanced equation. So whenever we are using a chemical equations, we are writing it as a balanced chemical equation. What is the need of balancing this equation? We are balancing the equation in order to follow the law of conservation of mass. That is, the mass of reactant should be equal to mass of product. According to law of conservation of mass, the mass of the reactant should be equal to mass of the product. For making the masses equal, we have to make the numbers of atoms equal on both sides. For that, we have to balance a chemical equation. Now, depending upon the type of changes occurring during reaction, we can categorize the chemical reactions into different types. 5 types we have to study in this lesson. That is combination reaction, decomposition reaction, displacement reaction, double displacement reaction, and oxidation reduction reaction. The first type of reaction is combination reaction. In combination reaction, 2 or more elements or compounds combine together and we are getting a single product. And it can be generally represented like this: A plus B giving C. Here 2 reactants, that is A and B, are reacting and we are getting a single product C. Okay. Now one example given here is 2Mg plus O2 gives 2MgO. That is, magnesium is combining with oxygen. That is the burning of magnesium ribbon. So during burning of magnesium ribbon, magnesium is combining with oxygen and forming magnesium oxide. A single product is formed here. So this is an example for a combination reaction. Okay. Then during that chemical reaction, along with magnesium oxide, heat and light also produced. So that also we can include in this equation. Then the next example we have to study is the reaction between calcium oxide and water. When we are adding calcium oxide in water, we are getting a single product, that is calcium hydroxide, CaOH twice. Okay. Now this reaction is also known as a combination reaction because here two compounds, calcium oxide and water, they are combined together and we are getting another compound, that is calcium hydroxide. Then why we are writing plus heat in the product side? To show that in this reaction heat energy is produced. During this reaction heat is produced. That is why we are writing plus heat in the product side. Okay. Such reactions are known as exothermic reactions. The reactions in which heat energy is produced, that is known as exothermic reaction. So this reaction is an example for an exothermic reaction. Now the calcium oxide or CaO, it has one more name, that is quicklime. That is the common name. CaO is also known as quicklime and CaOH twice is also known as slaked lime. Okay. The second type of reaction is decomposition reaction. It is the opposite of combination reaction. In combination reaction we have seen that two or more substances are combined together and we are getting a single product. But in decomposition reaction, a single substance breaks down to produce two or more products. That is known as decomposition reaction. So it is generally represented like this: A giving B plus C. A is the reactant, B and C are the products. Okay. So a single substance breaks down to produce two or more reactants. That is known as decomposition reaction. And for breaking a single substance, energy is needed. And this energy can be given either in the form of heat or light or electricity. So depending upon that, we can divide decomposition reaction into three types, that is thermal decomposition reaction, photochemical decomposition reaction and electrochemical decomposition reaction. First one is thermal decomposition reaction. The decomposition reaction carried out by absorbing heat, or the decomposition reaction carried out by heating. That is known as thermal decomposition reaction. If you are heating any substance, that substance breaks down to produce two or more substances or two or more product. That type of reaction is known as thermal decomposition reaction. The examples we have to study are the decomposition of ferrous sulfate. Ferrous sulfate on heating produces ferric oxide Fe2O3 plus SO2 plus SO3. Like that, lead nitrate PbNO3 twice. When we are heating, breaks down to produce lead oxide, nitrogen dioxide and oxygen. Like that, calcium carbonate on heating decomposes to produce calcium oxide and carbon dioxide. Here it is not CO, it is CO2. Okay. The color changes during this reactions also you have to study. In the first one, that is the decomposition of ferrous sulfate, what is the color change occurring? Ferrous sulfate is pale green in color, that is changing into reddish brown due to the formation of Fe2O3. Okay, Fe2O3 is having a reddish brown color, so we can see a color change from pale green to reddish brown, and we will get the smell of burning sulfur due to the formation of these gases SO2 and SO3. Like that, in the second one, lead nitrate is having a white color and it is changing into lead oxide PbO on heating, and that PbO is having a yellow color. So we can observe the color change from white to yellow. And the other two product NO2, that is nitrogen dioxide and oxygen, they are gases, and this nitrogen dioxide is having a brown color. So during that reaction, two changes we can observe, that is white color is changing into yellow color. At the same time, we can observe the evolution of a brown gas. Okay. Now in the third one, we cannot see any color change. Okay. Now the second type of decomposition reaction is photochemical decomposition reaction. It is the decomposition reaction carried out by absorbing light. In presence of light, some compounds, some chemicals are undergoing decomposition or breakdown. That type of reaction is known as photochemical decomposition reaction, and the examples we have to study is the decomposition of silver chloride. When we are keeping silver chloride in presence of sunlight, it is splitting and producing silver and chlorine gas. Here we can see the color change, that is silver chloride is white in color and it is changing into grey color due to the formation of this metallic silver. Like that, the second example, the decomposition of silver bromide. Silver bromide, when we are keeping in open air, it is breaks down and forming silver and bromine gas. Here also one color change we can observe, that is yellow. Silver bromide is yellow in color, that is changing into grey due to the formation of this metallic silver. Okay. Now the third type of decomposition reaction is electrochemical decomposition reaction, that is carried out by absorbing electricity. When we are passing electricity through some compounds, they are splitting. They are undergoing dissociation and producing two or more product. That type of reaction is known as electrochemical decomposition reaction. An example for that is the decomposition of water. Water, on passing electricity through it, splitting and producing its constituent gases, that is hydrogen and oxygen. I think we are remembering the figure and all we have studied, that activity, the electrolysis of water. Okay. So that is the example we have to study for the electrochemical decomposition reaction. Now the fourth type of reaction, that is displacement reaction. Okay. Displacement reaction means the reaction in which a more reactive metal displaces a less reactive metal from its salt solution. The more reactive metal is displacing a less reactive metal from its salt solution, that is known as displacement reaction. The general form we can write like this: AB plus C gives BC plus A. Here C is more reactive than A. Both C and A are metals and C is more reactive than A. So C is replacing A and we are getting BC. Okay. BC plus A. One example for that reaction is Fe plus CuSO4 gives FeSO4 plus Cu. In this reaction, which are the metals? Iron and copper are the metals. And iron is more reactive than copper. As a result, iron is displacing copper from copper sulfate. So we are getting FeSO4, that is ferrous sulfate plus metallic copper. So this type of reaction is known as displacement reaction. Now the fourth type of reaction is double displacement reaction. Double displacement reaction means the reactants, they are exchanging their ions. That reaction is known as double displacement reaction. The reaction in which the reactants are exchanging their ions, that is known as double displacement reaction. So these reactions are carried out in aqueous solutions. That means these compounds or chemicals we are dissolving in water and preparing their aqueous solutions. And these aqueous solutions we are mixing together, and as a result these chemicals are splitting into ions and the reactants are exchanging their ions. That type of reaction is known as double displacement reaction. For example, BaCl2 plus Na2SO4 gives BaSO4 plus 2NaCl. Here barium chloride, BaCl2, is a solid substance, so we have to dissolve it in water to prepare its aqueous solution. Like that, Na2SO4, sodium sulfate, so also a solid substance, we have to dissolve it in water to get it aqueous solution. So both these aqueous solutions we are mixing. As a result, these reactants, they are splitting into ions. BaCl2 is splitting into Ba2 plus ion and Cl minus ion. Like that, Na2SO4 splitting into Na plus ion and SO4 2 minus ion. So these reactants, they are exchanging their positive and negative ions. And as a result, we are getting two products, BaSO4 and NaCl. Okay. And out of these two products, one product is not dissolving in water, so it will form as a precipitate. And here BaSO4 is the precipitate. Like that, in the second reaction also, the reactants, they are solids, so we have to prepare their aqueous solution. Lead nitrate and potassium iodide, we have to prepare their aqueous solutions, and then we are mixing with each other. As a result, we are getting two products, lead iodide, PbI2 and KNO3. potassium nitrate. Out of these two products, lead iodide is a precipitate. That means it is not dissolving in water, so it will form as a solid substance. Okay. So during these reactions, during these double displacement reactions, a precipitate is formed always. So these double displacement reactions are also known as precipitation reaction. Okay. Now in this first example, the reaction between barium chloride and sodium sulfate. Do you remember what is the color of the precipitate formed? Yes, it was white in color. Barium sulfate is the precipitate and it is white in color. Then in the second one, the reaction between lead nitrate solution and potassium iodide solution, lead iodide is the precipitate formed and it is yellow in color. Okay. Now the last type of reaction we have to study is oxidation reduction reaction. What is oxidation? Oxidation means it involves the gain of oxygen. Whenever a substance is gaining oxygen, that change can be called as oxidation. Or it involves the loss of hydrogen. That means whenever a substance loses oxygen, that change can also be called as oxidation. Okay, like that reduction. It is the opposite, just opposite of oxidation. Reduction involves the loss of oxygen or gain of hydrogen. Now the reactant which is undergoing reduction, that is known as the oxidizing agent, and the substance which is undergoing oxidation, that is known as the reducing agent. And in most of the reactions, this oxidation and reduction occur simultaneously. That means if one reactant is undergoing oxidation, the other reactant is undergoing reduction. So oxidation and reduction are occur simultaneously. Such reactions are known as redox reactions. For example, Fe2O3 plus 2Al gives Al2O3 plus 2Fe. Here Fe2O3 is losing oxygen and changing into Fe. In Fe2O3 oxygen is there, that oxygen it is losing and changing into Fe. So we can tell that Fe2O3 is undergoing reduction. Like that aluminium, Al, it is gaining oxygen and changing into Al2O3. So that change can be called as oxidation. Okay, aluminium changing into aluminium oxide, that change can be called as oxidation. So the substance which is undergoing oxidation, that is the reducing agent. So aluminium is the reducing agent and Fe2O3 is undergoing reduction, so it is the oxidizing agent. During this reaction, Fe2O3 is undergoing reduction and aluminium is undergoing oxidation. Both are taking place simultaneously. So this reaction can be called as a redox reaction. Now the next one we have to study is corrosion. This is one type of oxidation reaction occur naturally. That means when we are keeping the metals in the open air, these metals are reacting with atmospheric gases like oxygen, carbon dioxide, water vapor, etc. to form metal compounds. And these metals are slowly undergoing destruction. That destruction of metal can be called as corrosion. Okay. Now if we want to prevent this corrosion, there are some methods. What are the methods to prevent corrosion? We can apply oil or grease, or we can apply paint on this metal, or galvanization, or alloying. Alloying means we can mix metals with other metals. That method is known as alloying. As a result, we can reduce the destruction of metals, that is corrosion. Okay. Our last topic is rancidity. That is also one type of oxidation reaction occur naturally. That is when we are keeping these oil content food items for a long time, this oil content present in those food items will react with oxygen in the atmosphere and changing into some harmful product that produces a bad smell and a taste. That phenomenon is known as rancidity. The oil content of the food items produces a bad smell and taste. that is known as rancidity, and that food item is known as rancid food item. Now what are the methods to prevent this rancidity? We can add some chemicals which will prevent this oxidation of this oil content. They are known as antioxidants. So by adding antioxidants we can prevent rancidity. The next method is vacuum packing. Some food items, when we are packing, we are removing the air from that packet. As a result, oxidation can be prevented, so we can prevent rancidity. Like that, one method is flushing with nitrogen. When we are packing these food items, we are filling that packet with nitrogen instead of air. As a result, oxidation will not occur, so we can prevent rancidity. Then another method that we are using in our home itself, that is we can keep these food items in airtight containers. So in the absence of air, oxidation can be prevented, so we can prevent this rancidity. Then that is a common method, that is keeping in refrigerator. In refrigerator, due to the low temperature, oxidation can be prevented, so we can prevent the rancidity. Okay, so these are the main topics you have to cover from the first lesson. I think it is clear for all of you, so study well. Okay.